Welcome back to Mythbusters, the podcast edition. Today, we're diving into a question that might sound silly at first, but its answer hides fascinating scientific truths. Is water wet? Today's myth isn't a myth in the traditional sense. Rather, it's a common but potentially misleading concept. Water is wet. Think about it for a moment. When you touch water, it feels wet. When a drop of water falls on your shirt, the shirt becomes wet. It seems so obvious. But is water itself inherently wet? Or does it possess the property of wetting other things upon contact? To answer this question, we need to understand two fundamental scientific concepts: cohesion and adhesion. Cohesion is the force that attracts molecules of the same substance to each other. In the case of water, water molecules, H2O, are strongly attracted to each other due to hydrogen bonds. This is why water droplets try to maintain their spherical shape and don't easily fall apart. Adhesion is the force that attracts molecules of one substance to molecules of another, different substance. When water comes into contact with another surface, like your shirt or your skin, the water molecules are attracted to the molecules of that surface. Now, when we say something is wet, we mean that water molecules have adhered to its surface. In other words, water itself isn't wet because it's made of water molecules bonded to each other, cohesion. But when water molecules come into contact with another surface and the force of adhesion between the water and that surface is stronger than the force of cohesion between the water molecules themselves, the water sticks to the surface and makes it wet. So water isn't wet by itself, but it possesses the property of making other things wet. Imagine a glass of water. The water inside the glass isn't wet itself, but the inner sides of the glass that touch the water become wet, as does your hand when you touch the water. It's an interactive relationship between the water and the other surface. Let's move on to another everyday scientific puzzle, also involving liquids. If you throw a flat metal coin into water, it sinks, while giant ships made of metal float. Why? This is a perplexing observation for both children and adults. A small metal coin sinks instantly, while a huge ship weighing thousands of tons and composed of vast amounts of metal gracefully floats on the surface. Is this magic? No, it's physics. The secret lies in the concepts of density and buoyancy, or Archimedes Principle. Density is the mass of a substance divided by its volume. A metal coin is almost entirely made of a high-density material, like copper or steel. When you drop it into water, its density is much higher than that of water, so it sinks. As for the ship, even though it's made of heavy metal, its design causes it to displace a very large amount of water. The interior of the ship isn't solid, it's mostly filled with air, which makes the average overall density of the ship, including the metal, air, and empty spaces within it, less than the density of water. This is where buoyancy comes in. When an object displaces a volume of fluid, the fluid exerts an upward force on that object equal to the weight of the fluid displaced. A ship is designed to displace a volume of water whose weight is greater than the weight of the ship. Therefore, this buoyant force is sufficient to push the ship upwards and keep it afloat. If the ship were to fill with water, its density would become higher than that of water, and it would sink completely. So, it's not just the material an object is made of that determines whether it will float or sink, but more importantly, its average overall density and the volume of water it displaces. And that's all the myths and everyday mysteries we've busted for you today. We hope you've gained some new insights into the world around us. Join us next time on Mythbusters, the podcast edition, for more fascinating facts and debunked beliefs. Don't forget to like, subscribe, and share.